Alright, thank you for joining the second part of my video on law, sine, and cosine application. Question 3. Christian, Deacon, and Aiden are on 3 separate boats at sea. Okay, I wonder what they're doing, but let's not ask, even though I just asked. Christian sees both Deacon and Aiden. Okay, so this is from basically the Christian's perspective, so I'm going to put a point here, K, and it says the angle between the line of sight to Deacon and the line of sight of Aiden is 45 degrees. So from Christian, I'm right now looking at Aiden, and I'm also looking at Deacon. Of course, this could have been a obtuse triangle. I don't really know, but I'm just putting like numbers and just following along. And so it says again, the angle between the line of sight to Deacon and the line of sight to Aiden is 45 degrees. So, oops, that is not 45. Let me erase that. 45 degrees. And then, well, obviously this is going to make a triangle, so I'm going to draw a line over here. And it says, what else? If the distance between Christian and Deacon is 2, so again, which one? Christian and Deacon, so this is 2 miles. And the distance between Christian and Aiden is 4 miles. What is the distance between Deacon and Aiden? So this would be my x. I think the most difficult part of this problem is to actually just draw the diagram. After you draw the diagram, let's see what we can do. First, I think law of sine. Law of sine, I have to use x, so I match up with 45. But then 4 matches up with an angle I don't know. 2 matches up with another angle I don't know. And so law of sine's no good. So the next best thing, law of cosine, which we do have. I have 2 sides and an angle, and I'm looking for the opposite side. Awesome. So that means using the law of cosine, c squared is equal to a squared plus b squared. I'm getting tired again. ab times cosine of c. Okay, which one's c, a, and b? The 2 sides next to the angle is going to be my a and b, and this guy is going to be my c. Okay, so I get x squared is equal to a, I said was 4. Of course, a and b could be either one, it doesn't matter. And then 2ab, so 4 times 2 cosine of 45 degrees. And again, I'm a calculator. I'm just going to type in everything. So what do I have? I have 4 squared plus 2 squared. And of course I could, whoa, what's that 0? That kind of freaks me out, so I'm going to do it again. But I know what 4 squared is. 16 plus 2 squared is 4 minus 2 times 4 times 2. Yeah, I could have done that too, but I'm lazy. Cosine of 45, and boom. Oh gosh, I don't like that. I want a decimal. I think I pressed this button. Yeah. So I'm going to keep it as a decimal. I guess you could keep it as a, that's actually a, what is it called? A, why is it slipping off? Going back, this is called a complex number, right, because of the square root. Okay, complex number. Anyway, I'm going to keep it as a decimal, so I'm going to write down x squared is equal to 8.68629. Okay, and then I just have to take the square root, so I'm going to take the square root, again, plus and minus square root, so x is equal to plus and minus square root this number. And so I'm going to actually do that over here. Take the square root of that answer. Boom. And I got my answer. Yay! And it says round to the nearest hundredths place. So that's what I'm going to do. X is equal to 2.9. Okay, so I'm going to say 2.9 miles between, who was it? Deacon and Aiden. Alrighty, so that wasn't too bad. Again, the diagram was difficult to maybe figure out. Now, for, like I said in my, what was it? In my comments, I posted a video of how to do this. Somebody did it for us, right? A different problem, very similar, but they used, or they didn't use law of sine or cosine. And these problems I actually recommend that you use law of sine or cosine. So let me show you how. So the first thing you do when you see a problem with two triangles like this is to label or try to figure out all the angles in the problem. Now, you could read the problem yourself, but the diagram is pretty self-explanatory. It gives you everything, and we're trying to figure out the height of the tower. So maybe I'll call that T, actually, because it's a tower. So I'm going to call it capital T. Why not? Okay, so like I was saying, when you want to use, well, when I see two triangles like this, and when you see two triangles like this, it's very likely that you're going to use law of sine or cosine. And so with that said, the procedure is to figure out the angles. So how do I do that? Well, the first angle I see right here, I could figure out easily is this. And I know because this is a linear pair, meaning it's on a straight line, meaning the two angles add up to 180. So I know this angle is going to be 180 minus 65, which gives me 115 degrees. And since this is a triangle, I know that this angle is just 180 minus the 115 I found, minus the 32, and I get 33 degrees. And now, why is that helpful? Because now I could apply the law of sine and figure out this side right here. Now, it might not be obvious, right, if you haven't seen a problem like this before, but why do I want to figure out this wire right here? Because once I figure out this distance right here, I could use the fact that this is a right triangle and use sine, cosine, or tangent to figure out the missing side. So you'll see what I mean after I figure this out. So this wire, this distance right here, I'm going to call W. So let me actually draw the triangle as best as I can. And so I saw that this is 32 degrees and this is 33. I'm going to ignore that 115 just because I'm not going to use it, but I did use it to figure out the 33. Now, I only drew this because I just wanted to show you more clearly how I'm using law of sine to figure out what the length of the wire is. So using law of sine, so I'm going to say A over sine of A equals B over sine of B. Okay, so let's look at this one. A, the lowercase a is the side, so I'm going to say 100 over sine of 33 degrees is equal to, over here, which one's the side? It's the W, so W over sine of 32. I'm going to cross multiply and do all that good stuff, and when I do that I would get W times sine of 33 is equal to, and I'm going to multiply 100 times sine of 32. What is that stupid plus sign doing here? Delete. Okay, so 100 sine times 32, and I got 52,992. Why not? Okay, and then I have to divide that number by sine of, oops, you can't see what I'm doing right here. So I cross multiplied and got this number right here. And then now I gotta divide by sine of 33 since I'm multiplying by sine 33. So I'm gonna do that on my calculator. I have that number and I have to divide it by sine 33 divided by sine 33. Boom. And I got my, well, not my answer, but I got the length of the wire. W is equal to 97.2973. Okay, so now that I have that, what am I going to do? I'm going to go back to this diagram. So now I know what W is, and I'm actually going to draw this triangle over here. And what does that triangle look like? It's a right triangle. And this angle is 65 degrees, and that's my tower T. And I found out W was 97.2973. And like I was saying earlier, I wanted this W because I have a right triangle, and right triangles are super helpful. In this case, I could use SOHCAHTOA. I shoot my arrow, so that's my opposite side, and this is my hypotenuse, and this is my adjacent. So which trig function relates the angle with the opposite and hypotenuse? So ka, to, wa. In this case, it is the O and H that I have, so that means I want to use sine. And the formula is sine of the angle is opposite over hypotenuse. Oh no, you can't see, sorry. So again, given this, I know I'm given O and H, so that means I want to use SO, or the sine, and the formula is sine of the angle is equal to the ratio of the opposite over hypotenuse. So now I just plug in everything. Sine of 65 is equal to O over H, so that's T over 97.2973. And that math problem is super easy. All I have to do is just multiply by 97.2973, and I'm going to do that in my calculator, and my number is still there. Yay! So that means I just have to say times sine of 65, boom. I get T is 88.18, but the problem says find the height of the tower to the nearest foot, so I'm going to say the tower is 88 feet tall. So, again, when you see a problem like this with two triangles and you can't use like standard methods like the Pythagorean theorem or maybe something else, and then it might be easier to try to use law sine and cosine. And again, the procedure is to first figure out the angles. And now that you have all the possible angles that could help you, you could try to use law sine or cosine. And that's what I did to find W, use the law of sine, and then once I did that, I used the fact that this is a right triangle and used just the classic trig functions. Alright, well, thank you for joining me. Sayonara!